This movie is for Learning Target 4-5, Slope-Intercept Form. We are going to graph equations in slope-intercept form. And then we're going to be able to write the equations from a graph. So first we have to remember slope. If we look at this, we've got an equation for a line. It says f of x equals 1.5x. And as I increase the slope, you can see what's happening to the line. The line is getting steeper. And as I decrease, the line is getting more horizontal, closer to a slope of 0. Then we can add a y-intercept. And as we increase the y-intercept, we can see that the line translates up the graph. And as I decrease the y-intercept, it translates down the graph. So we're going to put these ideas together to graph slope-intercept form. There's a game online, Algebra versus the cockroaches, and I'm not going to go there, but I put a link on It's Learning if you would like to play this game. It's good practice for reminding your brain on slope and graphing in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. So the m is telling us how much the graph is changing as far as being steep, and the y-intercept is telling us where it's hitting the y-axis. Let's go ahead and graph the equation y equals 3x minus 5. Let's identify the slope and the y-intercept first. So if I write y equals mx plus b, underneath my equation you can see that m is 3 and b is negative 5. So we start by graphing the equation with our y-intercept of negative 5 and a slope of 3, written as a fraction, is 3 over 1. So I'm going to go up 3 to the right 1, up 3 to the right 1, and graph my line. So a quick refresher on how to do slope-intercept form. We're going to do a couple more examples. Hopefully this will refresh your brain. Y equals x plus 2. First identify your slope, identify your y-intercept, and go ahead and graph. You can pause the movie and then press play when you're ready. All right, identifying our slope. Y equals mx plus b. M is 1, which is written 1 over 1. B is 2, so we go to 2. Plot our y-intercept and use our slope to get more ordered pair solutions. We see that we have an increasing line with a slope of 1. It's positive, so it should be increasing. It's a good way to check yourself. Let's go to the next example. Y equals 1/4 x minus 5. Go ahead and pause the movie, graph it, press play when you're ready. So we have y equals mx plus b. M is 1/4, so that tells me to go up 1 to the right 4. B is negative 5, so I start by plotting b. And then I use my slope of 1/4. 1/4 means up 1 to the right 4 because they're both positive. So I go up 1, 1, 2, 3, 4. And we graph our line. It's an increasing line. We have a positive slope. So that makes sense. Pause the movie, graph this equation, press play when you're ready. We have y equals mx plus b. M is negative 2/3. B is 6. So we're going to graph our y-intercept at 6. And our slope of negative 2/3, down 2 to the right 3. Down 2 to the right 3. We get our line. The slope was negative, and it's a decreasing line, so that should make sense. Go ahead and graph y equals negative 2x. Pause the movie, try it, press play when you're ready. Y equals mx plus b. Our slope is negative 2. We don't have anything there for b, so it's plus 0. We know that we're going to be going through the origin. So we start at the origin, we go down 2 to the right 1, down 2 to the right 1, and we get our line. All right. Now we're going to write an equation for a line. Given the line, we're going to write the equation in slope-intercept form. Y equals mx plus b. Two things you have to identify before you write that equation. The first thing is m, and the second thing is b. So we have to identify the slope and the y-intercept. So we have our y-intercept here. Finding some ordered pairs that are on the line. So I'm seeing where the line hits the grid at intersections, and I got these. So our slope is up 3 to the right 1. Up 3 to the right 1 is a slope of 3. Our y-intercept is right here on the y-axis, and that is at 2. Once you've identified these two ideas, you can plug it back into y equals mx plus b, and you get y equals 3x plus 2. Pause the movie, identify your slope and your y-intercept for this line. Press play when you're ready. Okay, our slope, I'm identifying points, and our slope is I went down 2 to the right 2, so it looks like I could have these as well. So I went down 2 to the right 2, that reduces to negative 1. Could you go down 1 to the right 1? Absolutely, it would be the same slope. Could you go down 4 to the right 4? Absolutely, it would be the same slope of negative 1. What is b? 0. So we get y equals negative 1x plus 0, or y equals negative x. Pause the movie, try this one on your own. Press play when you're ready. All right, identify the slope and the y-intercept. The y-intercept is here at 5. And then our slope, try to identify ordered pair solutions. I go down 1, 2, 3, 4, 5. So I went down 5 to the right, 1, 2, 3, 4. Down 5 to the right 4 gives me a slope of negative 5/4. For our y-intercept, it's at 5. So I plug that into my equation. I get y equals negative 5/4 x plus 5. This idea is a little different. We're going to be given two ordered pairs, and then we're going to write the equation in slope-intercept form that represents the line that goes through these two ordered pairs. And if you notice, there were a couple things that we needed before we wrote an equation in slope-intercept form. And those two things were the slope and the y-intercept. So I'm going to show you how to find those two ideas with two ordered pairs. The first thing we're going to do is slope, and we found slope with two ordered pairs before. So let's do slope between these two ordered pairs. I like to circle the y's, identify a direction. So I'm going to go negative 8 minus 1 over, and I have to do that same direction with my x's, 5 minus 2. So I get negative 9 over 3. Always reduce your slope. That gives you negative 3. So my slope is negative 3. The next idea I need to find is my y-intercept. Now neither of my points have x as 0, so I don't know what my y-intercept is. So what I'm going to do instead is go back to y equals mx plus b. couple things that I'm going to do. First, I already know what the slope is. So I'm going to replace that with 3. The next thing I'm going to do is I'm going to extract one of the ordered pairs that I was given. I'm going to take 2, 1. I'm going to take that ordered pair. I'm going to plug in 2 for x and 1 for y. Then that will allow me to solve for b. So 2 goes in for x, 1 goes in for y, and I get 1 equals 3 times 2 plus b. Notice, with that equation, I've plugged in values so that b is the only variable left. So when I solve this equation, I get what the value of b is. That'll give me my y-intercept. So now I'm just going to solve this. So 1 equals 6 plus b. I'm going to subtract 6. Negative 5 equals b. Now I have the 2 things that I need to write my equation in slope-intercept form. I have my slope and I have my y-intercept. So I go back to y equals mx plus b, plug in my slope, plug in my y-intercept, and I get my answer. Y equals negative 3x minus 5. So you first find your slope. Right here. Find your slope. Second, use y equals mx plus b. Choose one of the ordered pairs to plug in y and x. Plug in your slope and solve for b. Third, go back to y equals mx plus b. Plug in m, plug in b. So you're going to try this on the next problem. Given these 2 ordered pairs, I want you to go through the steps to write the equation through these 2 ordered pairs in slope-intercept form. So I'll kind of walk you through. The first thing you want to do is find the slope. So find the slope and then press play when you're ready. So the first thing you did was you did change in y over change in x. So I chose to use this ordered pair minus that one. So I did negative 3 minus a negative 2, which is negative 3 plus 2, and 1 minus 3, which is negative 2. So I get 1/2 for my slope. Now the second thing you want to do is go back to y equals mx plus b, plug in 3 for your x and negative 2 for your y, because I'm choosing that first ordered pair. Could you choose the next ordered pair? Absolutely. It doesn't matter which one you choose. They're both ordered pair solutions. So I chose the first one, 3, negative 2, and I'm plugging 3 in for x and negative 2 in for y. So that'll give me negative 2 equals 1/2 times 3 plus b. Solve for what b is. Press play when you're ready. All right. So we solve for b and we get b is negative 3 1/2. Now we're going to plug in the m, we're going to plug in the b to get y equals mx plus b. And we get y equals 1/2 x minus 3 1/2. And that is our y equals mx plus b. So we're excited about that. Okay, next one you're going to try all by yourself. Write an equation in slope-intercept form that represents a line that passes through these 2 points. Remember to find your slope, solve for b, and plug them both back into y equals mx plus b. Pause the movie, try this on your own, press play when you are ready. Okay, let's go through this. The first thing you did was find the slope. And the slope is negative 3 minus 1 over 10 minus a negative 6. So you get a slope of negative 4 over 16, or negative 1/4. Next, we're going to plug this back into y equals mx plus b, I use the point -6, 1. So I plug in -6 for x, plug in 1 for y, and that gives me my equation. So I'm solving for b, and I get that b is -1/2. Now I plug in my slope, and I plug in my b value, and I get y equals -1/4 x minus 1/2. That's the equation in slope-intercept form. Okay, let's go to the next one. Now we're taking a word problem that we're going to write an equation for. You take a taxi that costs $2 up front and 50 cents per mile. Write an equation for the total cost of the taxi ride. So the total cost will be dependent on how many miles I'm going to have to take the taxi. So we have our dependent variable and our independent variable. So the first thing we're going to do is define those two variables. So we know that our dependent variable, our total cost, will depend on how many miles we drive. So x, our independent, is number of miles. So our independent variable is number of miles, and our dependent variable is going to be the total cost. Now we're going to write our equation. And we know our total cost, y, is going to be, now you'll notice, this example follows slope-intercept form. Y equals mx plus b. B is our starting cost, our initial fee, that upfront cost that you need to pay. And when you get in the taxi, it's going to be $2 up front. So we know we're going to have +2 at the end. Now what fluctuates is that it's going to be 50 cents per mile that we're taking this taxi. So I know that it's going to be 0.5 times x, my number of miles. So my total equation is y equals 0.5x plus 2. What form is your equation in? Slope-intercept. Graph your equation. Think about the following. What variables will go on which axis? What's our independent? What's our dependent? What quadrants make sense to this problem? And what is an appropriate scale to use? So the first thing is I know that x is going to be my number of miles. Y is going to be my total cost. Quadrants. So if I look at a little graph, x being positive and y being positive makes sense. Quadrant 1 makes sense to this problem. Can I go a negative number of miles? No. So these quadrants don't make sense. Am I going to have a negative total cost? Will the taxi driver be paying me? No, not unless I'm a celebrity. And although I am very popular as a teacher, I don't think they're going to pay me. So we stay in quadrant 1. So it's going to look like what we call an L graph. So I'm going to show you what this looks like. When you're doing a graph, you want to have a title. And you can see that the graph is in quadrant 1 because I have, it looks like an L, my total cost on the Y, number of miles on the X, my X and my Y. And for my graph, I start with the y-intercept of 2, and I changed 0.5 to 1/2. So I went up 1 to the right 2. I was able to do that because I had a scale of 1 on this graph for both my x and my y. So I go up 1 to the right 2, up 1 to the right 2, and I get my graph. So make sure you have a title. Make sure you have the appropriate quadrants graphed. And that is either quadrant 1, maybe quadrant 1 and 2. It just depends on the problem. Mainly you're going to be working in quadrant 1. It makes sense to have positive values. Make sure you've labeled both axes. Make sure you have a good scale. And then you should see the graph. So I'm going to give you one to try on your own. It will cost $50 to rent a room for a party, $12 per person to eat at your party. Write an equation showing the total cost of your party. Answer these questions Then press pause and see how you did, or press play once you're ready, and then press pause again to graph it. So pause this, answer these two questions, press play once you're done with that. Okay, defining your variables. So again, we have total cost for our y value because our total cost is dependent on how many people come. So x is our number of people. Our equation is going to be in the form y equals mx plus b. So I have y equals my fluctuating cost, my slope is $12 per person. So I have 12x. Now my cost, my flat fee, is $50. It's not $50 per person. It is $50 to rent the room. That's sort of your down payment. It's going to be a flat 50. Now, I want you to pause the movie, graph this equation, and then press play when you're ready. All right, now that you have a graph for this, we should have a title, party, we're renting a party room. And we have our x-axis labeled, our y-axis labeled. It makes sense to work in quadrant 1 because we're not going to have negative people, and our total cost will not be negative. So I plotted some ordered pairs, 0, 50, and I used a scale of 12 because it was $12 per person. So as I increase in my number of people, then I can just go up $12 each for my y. And so that's your graph. See how you did. So that's the end of this movie. Thank you for watching.